Hello students, welcome to this lecture 1 Statistics. So in this lecture we will discuss exercise 13.2. Okay, so in this lecture we have the following table shows the ages of patients admitted in a hospital during a year. Okay, so we have here age in years 5 to 15, there are number of patients 6. When age between 15 to 25, there are number of patients 11, and when the age 25 to 35, there are number of patients 21. Okay, and for 35 to 45, there are number of patients 23. For 45 to 55, there are number of patients 14, and for age 55 to 65, there are number of patients 5. Okay, so here basically we have to find the mode and the mean of the data given above. So compare and interpret the two measures of central tendency. Okay, so first of all, find mode. Okay, so and mean. So to find the class marks xi, the following relation is used. Xi, this is equal to upper class limit plus lower class limit divided by 2. Okay, so taking 30 as you mean here. So here A is 30 and DI and FI DI are calculated are as follows. So when age in years 5 to 15, the number of patients FI 6, class marks 10, DI is minus 20 and FI DI is minus 120. Okay, so this is FI times DI. So for this class here, the class mark is 20, DI is minus 10, and FI DI is minus 110. And for this class here, XI is class mark XI is 30, DI is 0, and FI DI is 0. And for 35 to 45 for this class here, the class mark is 40, and DI is 10, and FI DI is 230. And for this class here, DI XI is 50, DI is 20, and FI DI is 280. And for this class here, XI is 60, DI is 30, and FI DI is 150. Okay, so now if we take total of number of patients, okay, so total number of patients, so that is summation FI, this is equal to 80 here, and summation FI DI, this is equal to 430. Okay, so if we add them, then you'll get summation FI DI, this is equal to 430. And now from this table we obtain summation FI, this is equal to 80, and summation FI DI, this is equal to 430. And now you can use the formula for mean, that is X bar, that is equal to assume mean A plus summation FI DI divided by summation FI. Okay, and here the assume mean is 30. Okay, so mean X bar, this is equal to 30 plus 430 by 80, and this is equal to 30 plus 5.375, and this is equal to 35.375. Okay, so this is approximately equal to 35.38. Okay, so the mean X bar, this is equal to 35.38. And now let us move to next we have to find the mode. Okay, so here it can be observed that the maximum class frequency is 23, that belonging to the class 35 to 45. Okay, so here the model class is basically 35 to 45, and here the lower limit of the model class is 35. Okay, and the frequency of the model class, this is equal to 23, and class size H, this is equal to 10, this is equal to 10, and frequency F naught, that is actually frequency of the class preceding the model class, that is equal to 21, and frequency F2 of class succeeding the model class, this is equal to 14. And now we know the formula mod of data. Okay, so mod, this is equal to lower limit L plus F1 minus F0 divided by 2F1 minus F0 minus F2. Okay, times H. So here the lower limit L is 35, and F1 this is 23, and F0 is 21, and F2 is 14. and age is 10. Okay, so if we put these values in this formula, then we'll get this is equal to 35 plus 23 minus 21 divided by 2 times 23 minus 21 minus 14 times 10, and this is equal to 35 plus 2 by 46 minus 35 times 10, and this is equal to 35 plus 20 by 11, and this is equal to 35 plus 1.81, and this is equal to 36.8. Okay, so mod is 36.8. So it represents the age of the maximum number of patients admitted in hospital was 36.8 years, and the mean of the data is 35.38. that it represents that an average the age of patient admitted to hospital was 35.38 years. Okay, so now let us move to next question. So in next question, here we have given the following data. So the following data basically gives the information on the observed lifetimes in hours of 225 electrical components. Okay, so we have given this table, and basically we have to determine the model lifetimes of the components. Okay, so let's solve this problem. So first of all, here from the data given above from the table, here it can be observed that the maximum class frequency is 61 and belonging to the class interval 60 to 80. Okay, so here the maximum class frequency is 61, and this belonging to the class interval 60 to 80. Okay, therefore model class is basically 60 to 80, and here the lower limit of the model class, that is L, is equal to 60, and frequency of the model class, that is F1, this is equal to 61, and frequency of the preceding of the model class, this is equal to 52. Okay, and the frequency F2 of class succeeding the model class, this is 38. Okay, and class size H is equal to 20, and we know the formula for mod, that is actually L plus F1 minus F0 divided by 2F1 minus F0 minus F2 times H, and we know all these values F1, F0, F2, H and L. Okay, so if we now substituting these values in this formula, then we'll get mod, this is equal to 60 plus 61 minus 52 divided by 2 times 61 minus 52 minus 38 times 20. Okay, so if we now calculate it, then we'll get this is equal to 60 plus 9 by 122 minus 90 times 20, and this is equal to 60 plus 9 into 20 by 32. Okay, so mod, this is equal to 60 plus 9 into 20 by 32, and therefore this is equal to 60 plus 90 divided by 16 is equal to 60 plus 5.625. Okay, and this is equal to 65.625. Okay, so therefore the model lifetime of electrical components is 65.625 hours. Okay, so model lifetime of electrical component is 65.625 hours. And now let us move to next problem. So in next problem, here we have the following data gives the distribution of total monthly household expenditure of 200 families of a village, and find the model monthly expenditure of the families, and also find the mean monthly expenditure. Okay, so we have given this table, and in this table here we have two columns. One is expenditure and other is number of families. Okay, so here we have given this data. Okay, data that is actually gives the distribution of total monthly household expenditure of 200 families of a village. Okay, so let us solve this problem. So it can be observed from the given data that maximum class frequency is 40, that belonging to the class 15 on 500 to 200 intervals. Okay, so actually they belonging to these intervals, and therefore the model class is 1500 to 2000. Okay, and here the lower limit L of the model class is 1500, and frequency of the model class f1, this is equal to 40, and frequency f0 of the preceding model class, that is equal to 24. Okay, and frequency f2 of class succeeding the model class is 33, and here the class size h is equal to 500. And we know the formula for mod of the given data, that is mod is equal to lower limit L plus frequency of the model class minus frequency of the preceding model class divided by 2 times frequency of the model class minus frequency of the preceding model class minus frequency of the succeeding model class f2 times class size h. Okay, so here we have these values. So here we have L is 1500, f1 is 40, and f0 is 24, and f2 is 33, and h is equal to 500. Okay, so now if we substitute these values in this formula, then you will get mod is equal to 1500 plus 40 minus 24 divided by 2 times 40 minus 24 minus 33 times 500. Okay, and this is equal to 1500 plus 16 by 80 minus 57 times 500, and this is equal to 1500 plus 8000 by 23. Okay, and this is equal to 1500 plus 347.86, and this is equal to 1847.826, and this is approximately equal to 1847.83. Okay, so therefore the model monthly expenditure was rupees 1847.83. Okay, so to find the, now we need to find the mean monthly expenditure. Okay, so first of all we need to find the class mark. Okay, so to find the class mark, the following relation is used, that is class mark is equal to upper class limit plus lower class limit divided by 2. Okay, and class size h of the given data is 500. Okay, so taking 2750 as you mean, that is a. Okay, so a is here 2750, and DI, EY and FIUI are calculated as follows. Okay, so here in this table we have calculated XI, DI, EY and FIUI. Okay, so this is FIUI. So here for this class, XI is 1250, DI is minus 1500, and UI is minus 3, and FIUI is minus 72. And for this class, here XI is 1750, DI is minus 1000, okay, minus 1000, and EY is minus 2, and FIUI is minus 80. And in this class, here XI is 2250, and DI is minus 500, minus 500, minus and UI is minus 1, and FIUI is minus 33, and so on. So you can see for other classes. Okay, so now if we add number of families, okay, that is summation FI, this is equal to 200, and summation FIUI, this is equal to 48. So from the table we obtain summation FIUI is 48 and summation FI is 200. Okay, so now you can find the mean, that is, you know, formula x bar is equal to a plus summation FIUI divided by summation FI. Okay, so if we now put the values, then you will get the mean. Okay, so the remaining portion for your homework problem. So let us move to next problem. So in next problem, here we have the following distribution. Give the state-wise teacher student ratio in higher secondary schools of India. So find the mod and mean of this data. So interpret the two measures. So number of students per teacher, Okay, they are actually in class, and number of states or UT are given here. So if you use this table, so it can be observed from the given data that the maximum class frequency is 10, belonging to the class interval 30 to 35. Okay, so therefore model class is 30 to 35. So model class is 30 to 35 and class size h is equal to 5, and lower limit of model class is 30, and frequency f1 of model class is 10, and frequency f0 of class preceding the model class is 9. Okay, and frequency f2 of class succeeding the model class is 3. So we know this formula, mod is equal to L plus f1 minus f0 divided by 2 f1 minus f0 minus f2 times h, and this is equal to here 30 plus 10 minus 9 by 2 into 10 minus 9 minus 3 times 5, and this is equal to 30 plus 1 by 20 minus 12 times 5. Okay, and this is equal to 30 plus 5 by 8, and this is equal to 30.625, and approximately this is equal to 30.6. Okay, so mod is 30.6, and it represents the most of the states or UT have a teacher student ratio as 30.6. So now to find the class mark, the following relation is used. Class mark is upper class limit plus lower class limit divided by 2. So taking 32.5 as assuming here, okay, and du, di, ui and fi, ui are calculated as follows. So here in this table we calculated di, ui and fi. So for this class, di is minus 15, ui is minus 3, and fi, ui is minus 9. And for this class here, xi is 22.5, di is minus 10, ui is minus 2, and fi, ui is minus 16. And for this class, di is minus 5, ui is minus 1, and fi, ui is minus 9. And for this class, di is 0, ui is 0, and fi, ui is also 0. And for this class here, di is 5, ui is 1, and fi, ui is 3. And for this class we have di is 10, ui is 2, and fi, ui is 0. And for this class we have di is 15, ui is 3, and fi, ui is 0. And for this class di is 20, ui is 44, ui is 4, and fi, ui is 8. So now if we take sum of number of states or UT, that is summation fi, this is equal to 35, and summation fi, ui, this is minus 23. Okay, so main x bar, this is equal to actually a plus summation fi, ui by summation fi times h, and this is equal to 32.5 plus minus 23 by 35 times 5, and this is equal to 32.5 minus 23 by 7, and this is equal to 32.5 minus 2.38 3.28, and this is equal to 29.22. okay, so therefore the mean of the data is 29.2. so the mean of the data is 29.2. So now let us move to question number 5. So here in question number 5, here we have the given distribution shows the number of runs scored by some top batsmen of the world in one-day international cricket matches. Okay, so we have given this table. So we have to find the mod of the data. So from the given data, it can be observed that the maximum class frequency is 18, and this is belonging to the class interval 4000 to 5000. Okay, so this is belonging to this interval class interval. So therefore the model class is 4000 to 5000, and lower limit of the model class is 4000. Frequency f1 of model class is 18. Frequency f0 of the preceding of the model class is 4, and frequency f2 of the succeeding of the model class is 9. So and class size is h is equal to 1000, and we know the formula mod is equal to L plus f1 minus f0 divided by 2f1 minus f0 minus f2 times h, and this is equal to 4000 plus 18 minus 4 divided by 2 into 18 minus 4 minus 9 times 1000, and this is equal to 4000 plus 14,000 divided by 23, that is equal to 4000 plus 608.695, that is equal to 4608.695. Okay, so this is approximately equal to 4608.7. So therefore the mode of the given data is 4608.7 runs. Okay, and now let us move to next question. So in next question, here we have a student noted the number of cars passing through a spot on a road for 100 periods each of the 3 minutes and summarize it in the table given below. So find the mode of the data. So here the number of cars given in this row. Okay, and here frequency are given. So from the given data, it can be observed that the maximum class frequency is 20 and belonging to 40 to 50 class intervals. So therefore model class is 40 to 50 and lower limit L of model class is 40 and frequency F1 of model class is 20 and frequency F0 of class preceding the model class is 12 and the frequency F2 of class succeeding the model class is 11 and class size is 10 and we know this formula mod is equal to L plus F1 minus F0 divided by 2F1 minus F0 minus F2 times H. And now if we substitute these values that means if we now substitute the value of L, F1, F0 and F2 and H, then we get mod is equal to 40 plus 20 minus 12 divided by 2 times 20 minus 12 minus 11 times 10. And this is equal to 40 plus 80 divided by 40 minus 23 and this is equal to 40 plus 80 minus 80 divided 80 over 17. Okay, and this is equal to 40 plus 4.7 and this is equal to 44.7. So therefore the mod of this data is 44.7 cuts. So here we get the mod of this data is 44.7 cuts. Okay, so for this question the mod of the given data is this given data is 44.7. So in this lecture basically we have covered NCERT exercise 13.2. okay, and here in this lecture we actually find mod of the given data and mean of the given data. Okay, so I stop here this lecture. Thank you very much to all of you.